Greetings, folks. So I'm not sure if Ms. Dunham is going to have a chance to come in and actually show you this demonstration. So I'm going to go ahead and make a video of it so that you can see it. The idea is the following. If you have a waveform that travels down a medium, like for instance, a string or a rope, you see a rope behind me, and that waveform bounces off an end and comes back, what you will end up with will be waves moving in one direction and waves moving in the other direction, and they will superimpose on one another. If you get just the right frequency, if the waves that are being generated, if the force that generates those waves is at just the right frequency, what you will find is that the superposition will be very orderly, and you will end up with what are called standing waves. One of the problems that you're going to have to figure out, or one of the problems that you're going to deal with in the next day or two, in all probability, is how do you figure out what the natural frequencies are of a system like this, so you can figure out what frequencies you would have to jiggle the system at to get standing waves. The fun part of all of that is actually being able to look and see standing waves. And so what I'm about to do is I'm about to show you standing waves that are being generated by this system. Anyway, that's the deal. That's what you're about to see. So at this point, I'm sending a wave down. It's not doing much. Going down and bouncing off. We're not getting anything too spectacular happening on the string. As I bring the frequency up though, what you start to see is what actually looks like kind of an interesting waveform. Notice that it gets big and then it gets small. What that means is I don't have quite the right frequency. I'm not driving it with quite the right frequency. So, once again, here it's probably not quite the right frequency, so it'll go for a while and then it'll die. But if I mess with it long enough, I should be able to get a waveform that looks pretty much like what you're seeing that is stable. If I increase the frequency, I will get what's called an n equals 2 state. So you have to remember, this is the consequence of waves traveling down, bouncing, and then superimposing on the waves coming in the other direction. And interestingly, if you get just the right frequency, you will find areas where the superposition is always such that there's no motion of the string at all. So this is called an O and node. This is called an antinode. Anyway, bringing the frequency up some more, this is called an n equals 2 standing wave. This is called an n equals 3